Ladies and gentlemen, please welcome Senior Vice President, NVIDIA, Jeff Fisher.
Thank you. Thank you, everybody. Welcome to Computex 2019. And I guess more importantly, thank you for joining us here today. We've got several things to cover today, so let me get started. First of all, I want to just talk about the past. About 26 years ago, NVIDIA was started, and our first vision, the vision of NVIDIA, was to create a brand new market, a market that we could see could grow. From the very beginning, we had growth strategies in mind. The market we were going after was the PC, turning the PC into a gaming platform. At the time, consoles were just starting to take off. But we saw the PC as really the prime opportunity to build a gaming platform. It was open, it was scalable, it was available everywhere in the world. We knew we could build a semiconductor, a chip, a GPU. We knew we could write software. But we needed a partner network. We needed partners to take a product out to market and go build a new market. And I remember one of my first trips was here in Taiwan, to go find partners who would share that vision. And we certainly found them. Over the course of time, this has become a very strong and powerful alliance between NVIDIA and our partners in Taiwan. So there's no better place to talk about growth, to talk about product, than here at Computex in Taiwan. I know we have many of our partners, hopefully all of them, in the room today. And this is to honor you for joining us in this journey. And we've certainly built an amazing market. Thank you. Well, I've got some good news for you, and as business people, maybe not so good news as parents. But what I want to say, and what I believe, is that every child born today will be a gamer. That's opportunity for us, and that's growth for us. And every child born today will be a creator. A memory keeper, everybody with a phone in their hand is a creator. These two markets represent a huge opportunity for us today and well into the future. Gamers and creators, there's a lot of overlap, but there's also a lot of distinct features and performance needed for each one of these markets. Today I'm going to spend time talking about these two markets specifically. Before I do, I want to, step back and talk a bit about growth strategies. NVIDIA's approach to growth strategies. And we're trying to think about how to do this. And one idea, I'm a bit of a Porsche fan, and we do a lot of research of various companies in the world, and one of the most successful companies in the world is Porsche. So I thought we could start by just talking about how they approach growth. In 1964, Porsche launched their 911 Carrera. That became their biggest selling car, sports car, over time, 1964. The 911 has sold 1 million cars to date. As time marched on, they tried to replace the 911 with a 914, a 928, but it continued to be their mainstream product. In the early 2000s, Porsche was looking at how do they expand? How do they become a bigger company? This is something NVIDIA faces, and this is something that all of our partners face over the course of time. And as you know, there's different strategies. We've all read about the blue ocean strategy, you go create a new market. And the red ocean strategy, you go attack your competitors. Well, NVIDIA thinks a lot like many companies in the world that go for new markets, such as Porsche. And in the early 2000s, they looked at how they can expand and enter new markets. The Cayenne was the first luxury performance SUV, entered a brand new market, created that market. The Cayenne is now over half of Porsche's revenue. Four-door sedan, performance, Panamera. Over time, multiple different models, the 918 Spider at the very high end, and I think I'm certainly excited about the new Taycan electric Porsche. So Porsche built new markets and became the most profitable car company in the world by going after and targeting different segments. This is a model, that is a model for a successful company who successfully grew and created new markets and entered. That's very similar to how we think about our market, our products, and how to partner with you to go and target and expand into new markets and drive growth. I could ask some of the audience, I don't know if Kent is here from ASUS hey, Kent. Our first product, our first graphics product, Riva 128. I know you remember it. Riva 128 was launched in 1996. This was our GPU. You could say our 911, if you will, our sports car. After Riva 128, we continued to expand in the graphics market and had built an entire family of GPUs. GeForce GTX, GeForce RTX. We've sold to date well over 1 billion graphics cards in this line of our product. We expanded that into notebooks. Around 2012, 2013, started the gaming notebook laptop market. Gaming monitors. Took our core technology and our brand promise into pro visualization, into the workstation market with Quadro. And now we're expanding our brand promise and our core technology into AI. Drive in autonomous vehicles, Jetson embedded robotics, HGX for deep learning in the data center, and our T4 server for inferencing in the data center. Our entire product strategy and our growth strategy has been to take our core brand, our core technology, and enter new markets. So let's talk about product now. Thank you for indulging me in this story. But I think it's a good way to describe how successful companies and how we partner together to go enter new markets. The gaming market, the gaming notebook gaming monitor market. NVIDIA launched G-Sync in 2014. G-Sync defined the first gaming monitor. 120 to 144 hertz, variable refresh rate. This was understanding the gamer, understanding the pain points of the gamer, tearing, stuttering, low frame rate, and collectively, we built a gaming monitor market starting with G-Sync. That monitor market, the gaming monitor market, has grown to somewhere between $3 and $3.5 billion this year, started by G-Sync. Earlier this year, we announced we're expanding our G-Sync market to G-Sync compatible, understanding that the growth of async monitors were an opportunity for us to offer more quality and validation to gamers. So we embraced the async market and picked those monitors that met the same standards of our G-Sync quality and performance and branded those as G-Sync compatible. Today we're announcing, this week we're announcing new G-Sync displays. G-Sync Ultimate 35-inch curved. G-Sync Ultimate is our 1000 nit HDR gaming monitor. G-Sync Ultimate 35-inch curved from Acer and ASUS. We've also brought G-Sync to the gaming notebook market. And the first G-Sync 4K 120 hertz laptops will be announced this week at Computex. 4K 120 hertz. The effort that goes into building a high-performance G-Sync laptop is pretty amazing. Not only do we have to team with the OEMs, HP, Asus, MSI to deliver these laptops, we have to go work with the panel makers, AUO, to build a variable refresh rate, high quality, high performance panel for the notebooks. First 4K, 120 hertz. And finally, 4K mini LED. 4 LEDs per pixel. Very high quality, very bright. The first 4K mini LED monitors are coming out as G-Sync Ultimate. 1000-nit HDR. We're also expanding our G-Sync compatible family, adding HP, Dell, and Samsung. So now every major monitor maker in the world is offering G-Sync compatible monitors. Brand new market, the gaming monitor market opened up by a partnership between NVIDIA and our ecosystem partners, starting with G-Sync in 2013, growing to over a $3 billion market. Laptops. The laptop market really started in about 2013. This was our architecture, our Kepler architecture in 2013 really got things going when Kepler redefined a new level of performance per watt, of power efficiency for laptops. But in 2014, we launched Maxwell. And Maxwell drove power efficiency even further. In fact, power efficiency has been a passion, a part of our architecture design from way back in the Kepler days. You could call power efficiency part of our DNA, part of our architecture DNA. With Maxwell, the gaming laptop market kicked off. In 2017, you may remember 2 years ago at Computex, Jensen stood up and he had a high-performance, traditional gaming laptop and a Max-Q thin and light laptop. We announced Max-Q here in Taiwan at Computex in 2017. Max-Q optimizes the design of the notebook and the design of the GPU to deliver very high performance, thin and light gaming. Max-Q continues to fuel this gaming laptop market, which is now the fastest growing gaming platform in the world, gaming laptops. We expect the end market for gaming laptops to approach $15 billion this year. And this is all revenue that you're driving. And we created together back in 2013. All told, there are 100 gaming laptops, over 100 gaming laptops that are launched this year alone. And here at Computex, there's another 9 that will be launched later in the week. Very important market, could not have been built without a collaboration between us and our partners. But every market isn't a new market that we enter, that we create. Some markets we have to renew. Some markets we have to reinvent. And reinventing markets is hard. Reinventing markets takes a lot of courage. But reinventing markets is super important to keep them vibrant. Because doing the same thing a little better or a little cheaper puts you in that red ocean. Markets need to be reinvented. And that's why last August, we announced Turing. Our Turing architecture, 18 billion transistors, the most complicated semiconductor ever built. Turing powers the world's fastest GPUs. And I believe, as of this moment today, that will remain unchallenged. Turing also powers the most power-efficient GPU in the world. I believe that will remain unchallenged as well. Turing focuses on delivering more instructions per clock. The Turing architecture has what we call concurrent floating point and integer. Float and int can run simultaneously, more instructions per clock. It streamlines graphics performance with a larger cache. So the Turing architecture in and of itself is our next generation architecture beyond Pascal. However, that doesn't reinvent. That makes our product a little faster, a little cheaper, and much more power efficient. To reinvent, we brought new features to gaming and to graphics. Tensor cores for AI performance, 130 teraflops of tensor ops, 130 tensor ops for AI. And we are bringing AI to graphics through a technology we call DLSS. RT cores. The other and most important innovation of Turing and GeForce RTX is real-time ray tracing through RT cores. 10 gigaarrays per second capability inside of Turing. And as you know, ray tracing is not a new thing. We did not invent ray tracing. Ray tracing has been around for years and a standard in the film and CG industry for creating lifelike lighting and images. However, ray tracing is done offline. It's very compute intensive. Gaming cannot use ray tracing unless it runs at real time, because our children want to play interactive real-time games, not wait minutes or hours per frame. So in order to deliver real-time ray tracing, we invented RT cores in our Turing architecture. To show you one of the more profound ways to describe Turing performance is through a single rendered frame of one of our flagship games called Metro. Metro rendered on one frame on Pascal. This is one frame of Pascal, and this time in the middle is spent ray tracing. On Turing, you can see several things happening here. One is green. That's our RT cores kicking in. The entire time that Pascal would be spent ray tracing is done in a fraction of the time on Turing. FP and int, the gray and purple, simultaneous, more instructions per clock. And then tensor cores for DLSS. We can deliver that same frame on Turing in roughly 20% of the time as on Pascal. And this is the horsepower, the core horsepower of Turing, and the reason we are so excited about this product. Reinventing graphics. NVIDIA and our partners have been driving Turing to market through a stack of products now that range from low end of $219, say $199, all the way up to $999. From the highest performance product at $999 all the way down to an entry gamer at $199. Super exciting. There's no question in my mind that real-time ray tracing is the next generation of gaming. Some of the most important ecosystem partners have announced their support and are now opening the doors for real-time ray tracing in games. Microsoft DirectX launched last November. Inside of DirectX 12 is now a ray tracing component they call DXR, DirectX Ray Tracing. It's every PC, if enabled by the GPU, is capable of ray tracing, accelerated ray tracing. And in fact, I think you know at GDC, at the Game Developer Conference this past March, we turned on DirectX ray tracing, accelerated ray tracing on our Pascal and Turing GTX GPUs. Microsoft DirectX. Vulkan, for the OGL games, supports now ray tracing. The most important game engines in the world, Frostbite, EA's AAA engine Frostbite, supports ray tracing. Unity and Unreal, which together power probably 90% of the world's games, now support Microsoft's DirectX ray tracing in the engine. Collectively, that opens up an easy path for game developers, thousands and thousands of game developers, to implement ray tracing in their games. You add to that the fact that I think every GPU vendor has said that they have hardware accelerated ray tracing on their roadmap. Sony announced that their PS5 would have hardware accelerated ray tracing. There is no question that the future for gaming is ray tracing. And we're leading, reinventing this market. And games are coming. All told, we're engaged somewhere in excess of 100 developers who are working on ray trace games. We have a pipeline of games coming later in this year and early next year. We're going to talk about a few of them in a minute. And gamers get it. Turing is outshipping Pascal from T0 of launch. To date, we have millions of gamers who are gaming on RTX hardware, accelerated hardware today. And that number is growing every week. So let's talk about some of the games. First of all, Quake II. Kent would remember Quake II. But Quake II is an iconic game. Quake II came out in the late 90s from id, and it was followed on a franchise of games from Doom to Quake II. And what we wanted to do, we're inspired by some work from some independents online to take an older game and make it cinematically beautiful by ray tracing it. We have a team inside of NVIDIA called Lightspeed Studios, whose function is to remaster existing games. Lightspeed Studios loved this opportunity and started working on Quake II. Let me show you some of the effects that are coming in our version of Quake II. This is the original game images. This is fully ray traced. We start with the original assets. We add lighting, we add reflections, we add God rays, atmospheric effects, diffuse lighting, where one wall is being lit from the light bouncing off another wall. You properly light the cracks with ambient occlusion. We're also taking the weapons in Quake II, and we're fully ray tracing them, adding new texture. You can see the reflection, the shiny reflection. Here you can also see the diffuse lighting, the ambient lighting bouncing off the walls. And here's a final image. Quake II, light streaming through the environment. You get the atmospheric effects. This is going to be one beautiful game and a lot of fun, not just for retro gamers, but for new gamers. And the exciting part is that we're going to be releasing Quake II RTX in partnership with Bethesda on June 6th. Free. 3 levels, free. You'll be able to get it from our website, and you'll be able to get it from Steam. This is going to be a lot of fun, super exciting. We're excited about what Lightspeed can do, ray tracing, remastering existing games. Later this year, we've got some more exciting titles that we're going to be talking about. Super fun. Next title, Wolfenstein, another partnership with Bethesda, another Vulkan RT game. We're teaming with Bethesda to bring real-time ray tracing to Wolfenstein Youngblood. In addition, another feature of the Turing architecture is called adaptive shading. Adaptive shading is a performance feature to add 15 to 20% performance by optimizing how the frames are shaded. Adaptive shading. We're going to offer a bundle of Wolfenstein starting May 28th, which is, I think, in tomorrow, 2 days, along with our RTX GPUs. And Wolfenstein is available, I believe, in August. So this is another exciting partnership for us, bringing ray tracing to a modern game, and it's going to be available in a bundle with our RTX products. Finally, partnering with Softstar Entertainment. Softstar is a Taiwan-based developer. They have a 20-year franchise game, a Paladin series. New game that they've announced earlier this year called Sword and Fairy 7. Millions and millions of China gamers love this franchise and are super excited about Sword and Fairy 7. We're announcing today that we're teaming up with Sword and Fairy 7 to bring real-time ray tracing to this game. Softstar is so excited about this partnership that today they are releasing, and we are going to show you for the first time, the video trailer for Sword and Fairy 7. So let's give this a run. All right. Did you notice the reflections? Did you notice the light bouncing off a light, lighting other environments. You'll see red coming from the flame. You'll see red in all the walls around it. Ray tracing really brings cinematic and beauty into games. And we're super excited about this partnership with Softstar and Sword and Fairy 7. Okay, so talked about new markets, talked about reinventing and renewing markets. Well, there's one more frontier that we want to talk about today. And that is creators. I mentioned every child born today is a gamer, and every child born today is a creator. There's 23 million YouTube channels. 400 hours of video are uploaded to YouTube every day. It's pretty amazing. But in YouTube, in all this noise, you've got to get noticed. In all this noise. How do you get noticed? You get noticed by increasing the quality of your content. Requires a much more thoughtful, skilled approach than just your phone. 25% of the global workforce are freelancing. Over half of the millennials in the US are freelancing, working for themselves, independence, and many of these are working in the creative field. That's obvious from Adobe's Behance program. I don't know if you're familiar with this. It's a portal inside of Adobe's ecosystem that allows freelancers to share their work with clients online. There's over 14 million Behance creators today, and that number is growing rapidly. Digital media has transformed how movies and TV shows are being distributed. Once again, in all that clutter, the quality of the content, the production value of the content is super important. 300,000 movies and TV episodes just this year. It's a staggering number. And the workflows of all this content is getting more and more complex. Requires more and more skill and more specialized hardware. So the opportunity inside of the creator market, we believe, is immense. And this is an opportunity that we plan on partnering with our ecosystem to go build and go drive. So why isn't it solved today? A creator who wants to buy hardware, wants to get the right tool for the right job, where do they go? Workstations, and this is a market we're very familiar with. Independent creators need to have accessibility. They need to be able to find the hardware. Workstations are generally a B2B type product. They're sold to large enterprises. They're also fairly expensive. So workstation market does not reach the broad field of creators around the world. Well, what about the Mac? It turns out, while the Mac has solved the distribution problem, the performance of the Mac is underpowered for a majority of creators. The workflow the Mac is great at is photos. But creative workflows are becoming more and more complex, as I mentioned. 3D rendering, 3D images are becoming more and more important to differentiate your work or become a part of your work. And 3D creators generally don't find the Mac to be the best platform for their work. And more of them are moving over to PC. The same is true with video. Video has 3D integration, and video resolutions are moving up from 6K to 8K and becoming more and more challenging where they need higher performance hardware. Gaming PCs. Why not just buy a gaming PC? Well, the creators we have talked to generally don't aren't that attracted to RGB. Those of you who know what I'm talking about. A lot of lights. Also, gaming PCs can lack the features necessary for creators. High-resolution displays, enough system memory, large frame buffers for giant workflows, for giant workspaces. If you're trying to run multiple apps, which is a very typical use case among creators, a gaming PC can choke on that. And DIY. Well, you can go build your own, but most creators want to focus on their work and are probably not that technical savvy to go build their own PC. We see it as a problem, and we see it as a pain point for creators. So we are announcing today what we call NVIDIA Studio. NVIDIA Studio is a platform that is built on our RTX GPUs. Creators need high performance. We're building NVIDIA Studio on top of our RTX GPUs. Studio has a software stack. This may not be a well-known or understood fact, but well over half of NVIDIA engineers are software engineers. We build one GPU, and we go after and create new markets with a software stack that is deeply integrated into the ISV ecosystem of that market. We have a studio stack that I'll talk a little bit more about in a minute. Well-developed SDKs, drivers that are designed to bring the heart and soul of a creative PC into this market. Perfect compatibility lab. You need to make sure the apps run. There's nothing worse to a creator than when they go to save their work and their PC hangs. That's a huge problem. Or they're moving between apps or windows and their PC hangs. Performance and compatibility is super important. We have a performance and compatibility lab for our studio program. We're working with over 200 creative apps as a part of our studio platform. Creators need to know where and how to buy their PCs. We're working with all the top OEMs to make sure that NVIDIA Studio PCs are available throughout the world to creators everywhere. And finally, we have a studio badge to indicate to a creator that this product is validated by NVIDIA and the OEM for the highest compatibility and performance and suitable for their needs. The NVIDIA Studio stack is our software stack built on top of our RTX GPUs. And it starts from the apps down with our SDKs. We have a broad range of rendering, video, and AI SDKs that are integrated into the creative apps so the creator gets instant access to all the capabilities of our GPUs. CUDA, which is our GPU accelerated language, translates the SDKs into what our GPUs can understand. And probably one of the most important attributes are our studio drivers. We launched about a month ago what we call our studio driver program. And our studio drivers are guaranteed compatible with the ISV apps. They run at a different cadence than our gaming drivers. Gamers want to make sure that their PC is lined up with every possible game that's launched. And we launch gaming drivers about every 2 to 4 weeks. Creators want to make sure that their system is compatible. They want it to be stable. They don't want a lot of churn. We will have a cadence of every few months, maybe once a quarter, a studio driver that is fully tested, downloaded from the cloud as an OTA into your studio-ready PC. And we're working closely with all of the top ISVs to test and fully validate our studio drivers and our stack along with their applications. The Studio Stack is really the heart and soul of the technology behind the Studio program. So today, we're announcing the first NVIDIA Studio laptops. And I've got one example here that we're going to talk about more in a little bit. Wasn't it running an app a minute ago? Studio laptops go all the way up to a Quadro RTX 5000, 16 gig frame buffer, 32 gig system memory. And that's what's in this laptop. Thin and light. Find me a creator that's not going to get excited about this. High performance GPU, large frame buffer, large system memory, Studio Stack validated. NVIDIA Studio laptops. So let's look a little bit at, let's look at the performance. Let's see if I can get back here. Let's look at the performance of these laptops. Ray tracing, I mentioned, it's becoming more and more important part of the workflow. Video editing. This is playing back a 6K video. You can see GPU accelerated compared to CPU. Let's look at that one more time. Playing back, decoding, and deburying video in real time. Now it's possible on a Studio laptop. Finally, AI. Remember tensor cores in RTX GPU. This is an AI example of just washing out an image, a part in real time of an image. I can imagine that being useful for some of my family pictures. And we've got some pretty cool demos we're going to show you in a bit. Performance, this is comparing our 2080 Max-Q Studio laptops to MacBook Pro. And of course, in workflow, when you're a creator, lower is better. 3 minutes to 24 minutes for 3D creation. Video, 3 minutes to 8 minutes video. Photos, 2 minutes to 10 minutes. Max-Q Studio laptop compared to Mac Pro. We don't mean to say Mac Pro is not a great product. What we mean to say is that our Studio platform and Studio laptops provide a huge opportunity for us to go after this creator market. So with that, I'm going to invite Jason Paul on the stage. Jason is our general manager of GeForce platforms, my team, and we're going to walk you through what some of these workflows are with some very special guests. Thanks, Jason.
Thanks, Jeff. Hello, everyone. So RTX Studio laptops are going to change the way creators work. And rather than show you this with some technology demos, we've invited 4 amazing artists here to Computex, both from Taiwan and around the globe, to share their art and their experiences using these laptops. And first, I would like to introduce Leo Chou and Jacob Norris. Leo is the CEO of TCImage. This is a architecture and interior design studio based in Taiwan that does amazing work in tools like Unreal Image to visualize their interior spaces. Hello, Leo.
Hi, 大家好. My name is Leo. We are strong in architecture and interior design experience for more than 10 years, and top of architecture 3D render and animation. Right now, welcome Jackpot. He is an NVIDIA RTX. He will show you real-time ray tracing in Chinese style interior. Please.
Let's take it away, Jacob.
Thanks a lot. So let's take a look here at this beautiful scene that Leo and I have collaborated on. And I'm going to talk a little bit about how ray tracing technology helps make the workflow so much easier with clients back and forth and speeding up the process. We're doing this in the Unreal Engine here. And basically, we can go ahead and finish out this living room that we've got. We still need to place some furniture in there. You can see all the real-time reflections working beautifully and the soft shadows coming in from the curtains there. If we start putting in some of our couches, we can see the lighting updating and the shadows coming through. And in the past, when you're doing this, it would generally take hours to bake this scene out, calculate every photon bouncing around the room. And now it's done in seconds, so you could be with the client showing them the furniture as you're placing it, and they can talk about, say, maybe the fact that this room's getting a little dark as I start placing some of the furniture in there. So let's go ahead and add ourselves a light in, wherever you think it's going to be best, and they could tell you right then and there, oh, my wife actually likes it coming in from the window, kind of mimicking that same sort of soft lighting coming from the window right there. And as you're placing this stuff, you say, oh, maybe it's going to get a little cold in the wintertime. Let's go ahead and put a carpet down there. Warm up your feet. And as a last little bit, let's light up this back area and get some cool shadows coming through this hand-carved, ornate wood structure that maybe your father put together for you. We're going to go ahead and increase the intensity just so you could really see those shadows coming through, and adjust the softness or the sharpness of those shadows based off of the type of lighting you want to have in the space. Let's lighten the space up a little bit and put some things on the table here for us. Get a little plant in there. And maybe finish it off with something to excite your brain.
That's amazing. Thanks so much, Jacob. So everything in this scene, the reflections, lighting, shadows, ray traced in real time, and allows the artists and designers to work interactively with their clients, make adjustments to the lighting in the space, and make it perfect just the way they want it, and visualize it before they have to start building. Really amazing stuff. And so, Jacob, you've been traveling for the last 2 months or so in Japan. How have you been doing your work? How have you been working on this project?
Well, I never imagined I'd get to work with ray tracing real time to begin with, let alone from a laptop anywhere in the world. So I can do that, and then after I'm finished, go and get some ramen for dinner.
Awesome. So yeah, this entire space working with Leo was all done remote on an RTX laptop. So really cool. Thank you guys. So next up, I would like to introduce Juan Salvo. Juan is the founder of the ColourSpace and is a world-renowned finishing artist, working with artificial intelligence to improve his video productions and enhance his video productions. So I'd like to turn it over to Juan to take us through it.
Thanks so much, Jason. Yeah, it's a real pleasure to be here. You know, at the ColourSpace, really our primary job is trying to make images look their best. And like all creative professionals, we're being asked to do more and more, faster and faster. So I wanted to show you today a few ways in which we're kind of leveraging the power of NVIDIA GPUs and DaVinci Resolve 16 here to kind of make that possible. So often our work actually begins on set, on location. You know, we're tasked with doing things like getting all the shots together, importing the footage, and kind of preparing it for editorial. right off the bat here, I want to show you a quick way in which we're using the DaVinci neural engine to kind of maximize our metadata and get some really useful information for editors. So I can right-click on these clips that I just imported, and I can say Analyze Clips for People. And this is a new feature inside of Resolve 16, which will, I'm just going to cancel out here, sorry, which will actually go through and analyze those shots and find the people in those shots and catalog where they appear in a scene. So I can actually go through and see all of the shots that this actor is featured in. Obviously, you know, when we get footage in, it's often in this kind of log state. It looks a little flat and washed out. We want to really make it look its best and make it fit with the rest of the show. So, and of course, color is the core feature of DaVinci Resolve. So I can very quickly apply a grade on here and get kind of the image looking right and get our shots looking nice and beautiful. Sometimes, you know, you'll have production issues or lighting issues, and you'll want to tweak certain things. We want to make sure everybody looks great. So one really useful feature that we have inside of DaVinci Resolve 16 here is this face refinement tool. What this allows us to do is kind of analyze the shot, and it'll go through and actually find the geometry of the face. You can see there it's tracking the chin, the lips, the nose, the eyes, the eyebrows. And so once we have this geometry tracked using the DaVinci Neural Engine and the power of the GPU here, we're able to go through, and I can actually show you, we can do things like, for example, smooth out the skin a little bit, maybe brighten them up. You know, we want to make sure they're well lit. We can do a little bit of eye retouch so we can really see kind of the eyes brighten up a little bit. You know, we can sharpen them up to make them pop a little, right? We can do a little bit of an eye light for like that romantic kind of lighting style, right? And so I'm able to do that very, very quickly, make drastic changes to the scene. And because I've used AI to track this face already, it's already tracking perfectly. You can see it's tracking with her lips, with her nose, with her eyes very, very quickly.
That is really cool. Hey, can you apply that filter on me? I'll get you the video after this
Yes,
show.
I'll start. That's another service we provide, is the personal face tracking service. So one other thing I want to show you here, obviously any program needs an opening title sequence, and our program here is no exception. You know, we have this lovely shot of Taipei here, and you know, we could, you know, just throw a show title over this shot, and you know, this is maybe the traditional way in which you would do typography or chirons over video, but you know, this is a special presentation. We want to make this a little bit more punchy. So one of the tools that we have available to us inside of DaVinci Resolve 16 in the Fusion page here is a tool called the Camera Tracker. And the Camera Tracker basically lets you go through, and we're going to load it up here. I'm just going to tell it to track the green channel. I'm going to say auto track. And what you'll see is it'll start pulling the 8.3 million pixels of a frame, analyzing it for features that it can track, pulling the next 8.3 million pixels, analyzing those, and tracking the movement of these features from one frame to the next to the next. So it's literally computing on the GPU billions of pixels into thousands of points, and then it takes those points and tries to compute out what the camera was doing in the scene. So we actually recreate the movement of the camera. So what this lets us do is, rather than just adding, you know, simple titles over video, we can add a title in the scene. And we can tell our stories a little bit better that way.
That's really awesome. So using the power of artificial intelligence inside of video workflows, you know, being able to make adjustments to a single frame, and then via face tracking and AI to apply those same adjustments to all the frames in a scene. This is incredibly powerful, time-saving features that are GPU accelerated and really just possible because of GPU technology and working with partners like DaVinci Resolve. Amazing stuff. So, Juan, as an artist, you probably have multiple projects you're always working on. You made time to come out to Computex, but I'm sure you still got to keep working. How do you do that?
Sure. You know, one of the things that makes it viable are these new sort of workstation class performance notebooks. You know, I was able to, for example, we came out here, and I have another client who's exhibiting a video here at the conference, and they had a last-minute tweak. I was able to have them post a file for me to download. I downloaded it onto my laptop, and I was actually able to work on it on the road. So, you know, we're talking about creatives being asked to do more and more. Sometimes we're asked to do things in strange places and so on trips, and so that's just the reality of working for a creative professional. It's great to be able to do it anywhere.
Awesome. Thanks so much, Juan.
Thank you.
Last but not least, it is my pleasure to introduce Daniel Gregoire. Daniel is the CEO and founder of HALON Entertainment, which is a visualization company based out of Hollywood, working with film studios and game companies to create amazing visualizations, and has worked most recently on a film you may have heard of called Aquaman, and is going to share that with us. Dan, thank you.
Great,
Welcome.
thanks, Jason. Thank you for having me. So yeah, we've been working in this film now, or in this field for about, HALON's been around for about 17 years, and I've personally been working in feature films now for 20 years. Time goes by. And I've been a director and a creator over that period of time, both for pre-visualization on feature films, but also games, as well as many other projects, including ride films. And what I'd like to show to you today involves the visualization of part of the third act of Aquaman. And if we could roll the final shot from the film, please, as a setup, that'd be great. So as you can tell, that's a big moment from the film, right? There's a lot of things going on. There's a lot of stories being told. It's the clash of these two titanic armies coming together in the third act of the film. And we were responsible for helping to seed some of these ideas in the early stages. In fact, they had already shot most of the film when we had started the project. And we were asked to come in and work on these big shots. And what I have here is actually that shot running real-time in Unreal Engine on this laptop right now, which is a Quadro-based RTX 5000 laptop. And there are thousands of objects in here, all from whales to ships to heroes and enemies and villains. And what's amazing about this is that something in the past like this would have taken weeks and weeks to prepare using DCC apps, etc. And now we're basically running this real-time in a game engine. And what I'd like to do now is actually show you the shot running. And this is the previs version of the shot, so it's a little different from the final, but you'll get the same story points here. And what we did was work with about 4 artists over 2 weeks and redesign this shot 3 times to get it close to the final. It went through about 82 different revisions. And the only way we could really do that so fast and to do it in such an articulate fashion with textures and explosions and particle systems and all that kind of stuff was really to do it real time in an engine. But what's also exciting about this is not only is this running completely fluidly on a laptop, but we could actually run this over to the director's office and work with, it was James Wan, work with him or the visual effects supervisor live, right? And not only that, but we're also ray tracing this now on a laptop, which is just stupendous. In fact, you can see some subtle differences here in the Karathan. Like if I turn on ray trace global illumination, you can see subtle differences in the way the scene gets lit. And this may seem very, maybe a little unnecessary for what we're doing since it's not the final pixels on the screen. But the closer we can get to the final imagery, the easier it's going to be for the hundreds of artists in the visual effects pipeline to get this shot looking the way the director has worked so hard to direct it in the earliest stages when we're involved. The other thing that is going on here is I'm going to go out of this cinema camera a little bit, is we're actually ray tracing a bunch of this stuff for reflections as well. And let me just slow this down a little bit so you can see it. If you look at the clamshell here, as I do a slow pass by, you can actually see all the whales and ships reflecting off of the top of this thing. And that maybe seems like a little bit of overkill, but like I said, the more details we can actually put in this, the easier it's going to be to get approval from all the parties involved to move the shot, into the final visual effects process. But even more importantly, when we work with the director, there's a lot of changes that happen. Like I said, this went through 82 different revisions. And as you can tell, there's a lot of things going on in here. And I think I forgot to mention earlier, this is actually about 172 million polygons in here, so it's not a light scene either. And so what I'd like to do is I'm actually going to change this just a little bit to demonstrate just a little bit about how flexible this can be and how working on a laptop in a director's office with the director sitting over your shoulder can be such a powerful way to work. I'm actually going to go in and change the focal length of this shot on the fly. So right now it's a 40 millimeter lens, probably based on some kind of anamorphic camera. I forget what they shot this on, but let's say I want to come in here at the end and do a little snap zoom to get a little bit more impact on the carafe and biting the clamshell. So I'm just going to set a keyframe here at that time, and then I'm going to go to the big chomp here, boom, and then I'm going to zoom in on that, maybe a 50 millimeter lens, just to get a little bit more impact on that bite. In fact, you know what? Let's get a little tighter. Let's do a 75, because you can never get too close to a big explosion like that. So you can see it animated here between 40 and 75, and then I'm just going to play that back so you can see the impact in the shot. Boom. So there we go. And it's really that simple. And since it's playing live, I can walk this into a director's office. They can make the changes. They can see them right there, right away, instead of me going back to my office, rendering it out, putting it into a cut, and then calling them the next day and saying, okay, you can look at this now. We can get this done now, today, without having to wait. And this means this shot can get turned over to visual effects and get moving through the production process that much sooner and more efficiently.
Awesome, Dan. That is really amazing stuff. And I don't know if you noticed, but that clamshell, curved surface, reflections off of a curved surface, super hard to do, critical with to have ray tracing for something like that. And Dan, you've been doing this for a while. What was your life like before high-performance laptops?
Sure. So, in my office, I work on a desktop, but we also go on set a lot. We field teams all over the world, actually. And we typically ship desktop workstations in Pelican cases to these locations, including on set, et cetera. And these things, they're big. They're very powerful, but they're heavy, and they can be a little inconvenient at times, especially when you're in a small trailer on set. And so now, I can put this in my backpack. It's right over here. In fact, I have another RTX-enabled laptop in my backpack that I work on regularly. And that means I can just walk onto set, show things, and have just as much power there as I would sitting at my desk back at my office.
Awesome. That is fantastic. So much of what we've shown here has been done before. In a large studio, on high-end workstations. But what we're showing here that's the first is being able to do this for an individual artist on a laptop that can be taken anywhere. And this is what is going to change how 40 million creators work. The power of RTX laptops enabled by ray tracing and artificial intelligence. So, thank you.
Thanks, Jason. That's really awesome. And thank you for joining us here today. That was really great. Demos were terrific. And I'm glad that we're able to change your lives in a little way. Thank you. Okay, so I know I talked about an RTX Studio laptop, but in fact, it isn't just a laptop. I mentioned that part of our Studio platform is making it accessible to creators all around the world. And we do that with partners, of course, as we always have. We're announcing today that there's 17 NVIDIA Studio laptops that are going to be available starting in June. You should be able to see them all around Computex, Acer, Asus, Dell, Gigabyte, HP, MSI, Razer, the first set of global partners. Over on the side of the room, when we wrap up, majority of these laptops are available to play with and see, running creative apps. And the price points of these laptops are starting, high performance, high res laptops are starting at $1599. Super exciting. We're really excited about the NVIDIA Studio laptops. Okay, so with that, let me wrap up. First of all, ray tracing is next-gen gaming. RTX GPUs, most powerful GPUs in the world. Best perf per watt, best power efficiency. Most advanced GPUs in the world, and we are redefining gaming. The apps are coming. Announcing 25 new laptops, bringing the total of laptops available this year to 125. This includes the gaming laptops and the studio laptops we just talked about. And announcing the NVIDIA Studio platform. Together, we're going to go target those 40 million creators. We're going to show them what's possible in their new workflows on a NVIDIA Studio laptop. Really excited about this. We thank our partners for joining in this pursuit, the OEMs, the ISVs, and of course, the platform that we've developed inside of NVIDIA. So with that, thank you all for joining us, Computex 2019. I hope you all have a super Computex. Thank you.